Now, since we have learned about the functions, the main three functions of the trigonometry, right? So then we might have a problem with how to find out the values, especially, for example, let's say, um, how to find out the sine theta, sine 30 value, right? If the angle value, which means the theta value is given, how to find the final answer, right? What is cos 45 value? What is tan 60 value? So in this kind of a situation, we can always use the trigonometric table actually, right? It has been already given for us, the specific values, right? So we don't need to exactly remember, but for the science, for technical subject, we can use a calculator for the exam. So no need to remember these things, but it's always better to remember it in case you want to calculate the questions very fast. Otherwise, it will take certain amount of time. Okay. So let me share it with you. Okay. So here we have the trigonometric table. Usually these are predefined values, right? And either you can use a specific technique to remember this one. There's no harm of remembering these things. Actually, it will be much easier when you are solving the questions for the final answers. So you can see from one side, one column, we have the sine, cos, tan, and we can have the values for 0 degrees. What is the sine 0 value? What is the cos 0 value? 30 degrees, sine 30, sine 45, sine 60, sine 90 degrees. Cos 0, 30, 45, 60. Okay. Let me show you one pattern here. Actually, you can easily remember. So you can see, obviously, if you write down these 5 columns, there are 5 columns, 0 to 90 degrees, and there are three rows here. So usually, if you create a triangle like this blue triangle, here you can see sine 0, cos 90, and tan 0 is always these three actually in 0th position. And if you take the exact opposite, let's say the other side, the other triangle, like this. So it is consist of the ones, right? So other side is zeros and the other side is the ones, consist of ones. So sine 90 is 1, cos 0 is 1, and tan 90 is actually, it is infinite number, so it is not defined. You can just remember it as a infinity. Okay. With that, in those two similarities, then I can move on to the other similarities you can use to remember this table actually. The one thing for sure, especially you can see if you closely observe these 6 values, you can see these are the exact same things, but in the opposite direction, right? For example, sorry, where is it? Right. Here you can see sine 30 is half, right? And cos 60 is also half. So these are similar. And sine 45 degrees and cos 45 degrees, it is equal to 1 divided by squared 2. 1 divided by squared 2. And sine 60 and the cos 30, they are also the same, right? Squared 3 divided by 2, you can see it is the same thing, right? It is the same thing. Now we have learned how many similarities there are. We have discussed about the two arrowheads and these three values. But you have to manually remember the tan values actually. You have to manually remember the tan values because tan 30 is equal to 1 divided by squared 3, and tan 45 is equal to 1, and tan 60 is equal to squared 3, right? So that is how we can, if you want to remember this one, that is the easiest technique we can use. Otherwise, since you have the scientific calculators, if I just put down the values, they will always get the values, right? It is not a necessity, right? Now the applications of the trigonometry, we have learned about the main three functions, right? So one application, find a missing side length given an angle measure, right? And now in the example 16, the example 16, we need to find out the x length, okay? We need to find out the x length. However, what are the data we have given? One hypotenuse length, it is 5, and this angle 30 degrees, okay? Now, if you have already learned about this, if you have already familiarized with these trigonometric functions, you can obviously see in front of your considered angle, this is what we called as, this is the opposite, right? We have given the opposite value as well as the hypotenuse value. What is the trigonometric function dealing with the opposite and the hypotenuse? Opposite and the hypotenuse, it is actually the sine value, right? And if you remember the sine equation, sine theta is equal to opposite divided by hypotenuse. Now, what is the theta value? Sine 30 degrees is equal to x. We don't know this value, but we know the hypotenuse. Then that is the next thing you have to learn about when it comes to the equations. You should be comfortably, you should be able to take out this x to one side of the equation, okay? So if you take the x out of the equation to one side, which means 5 is has to give to the other side, right? As a multiplication. So if I recall the sine 30 value from the trigonometric table, it is how much? It is the half value, right? Can you remember? Sine 30 is equal to half. So half times 5 means it is going to be 2.5. Now you can easily find out, okay, x value is going to be 2.5. And what are the other examples? What are the other examples of the trigonometry? Well, you can find out anything. Let me open the notebook for you, whiteboard. Yes, I think this is also, I think it is already shared with you. Right. Let's say when it comes to the trigonometry, I think you can see the screen. I think whiteboard is already, yes, the whiteboard is already shared. We have to separately share this one. Okay, right. Usually, let's say if you only have if you only know one side length of only two sides, you should be able to find out all the other values of the or any other length, especially if you can find out this length, this one, then you can find out this one, like that. So either you have to have two lengths, right? Or otherwise you can have one length and one angle, right? Or otherwise you should have at least, what I am saying here is that you should at least have two data. You should at least have two data to find out anything using the trigonometry, right? Either if it is a two length, or it may be a one length, let's say this length and this angle, like the question we have already done, or otherwise only two angles, right? That is enough for the trigonometry to calculate the rest of the values. With that in mind, let's again move it to the presentation. Here is also another example. You can see what are the data they have given. This one angle and one length, right? Now, first of all, when it comes to trigonometry, you need to find out what is the exact function we are going to use to find out the missing length or angle. So in this case, we have the opposite side, right? If it is not clear for you, this is the angle, this is the opposite, and now we don't know the hypotenuse. Instead, we have given the adjacent, right? So what is the trigonometric function dealing with opposite and the adjacent? It is the tan value, right? Tan theta is equal to opposite divided by adjacent. So tan theta value is how much now? 52 degrees is equal to 16 divided by x to one side, right? And here is also one simple solving method here. You can see, you can take this x to tan 52 sides, and you can transfer that tan 52 or whatever in this side to x value. That is one easy solving method. So x is nearly equal to 12.5. Now you might have a small question. So in the previous case, we take the sine 30, right? Sine 30, sine 45, sine 60, sine 90. Now we already know those values. But how do you find out tan 52 value? Tan 52 value. Well, no need to worry about that. You can use the scientific calculator. There is a sine, cos, and tan keys for that. You can put the tan, and there's a bracket opening with the tan function. You can put 52 and close the bracket and press the equal sign, then you will have the answer, right? Here's also one example. Can you determine what we have to find out in this case? Now this is much of a different approach actually. Let's look at the figure in the right side. Here we have the triangle. We don't know this theta angle. However, they have given this one as a 90-degree angle. So obviously we can use the Pythagoras theorem. And if it is 8, if it is 6, you can definitely find out what is the hypotenuse length, right? But actually in this case, we don't have to find out that. My next question is, what is the function we have to use here? So you have, this is the angle, we have the opposite and the adjacent. Again, you can put it as tan theta is equal to 8 divided by 6. Now this is a new case. Why? There's a difference in here. Now the theta value, we don't know the theta value. Obviously, in this question, we need to find out the theta value, not the length, okay? As I said earlier again, if I recall correctly, for trigonometry to use, we should at least have a one length or one angle, or otherwise two lengths or two angles, right? So here, this is the third scenario. We have the two lengths. Now we need to find out the angle, right? That's enough. Now the approach is somewhat differ. Rather than if we don't have the theta value, you can take out the theta like this, right? And there's a specific way of writing down or slowing down this question. Tan theta is equal to 8 divided by 6. Then you have to write down theta is equal to this one. Theta is equal to tan. This one is called as tan minus 1, tan inverse. Tan inverse, exact same. The exact same number format. 8 divided by 6. Don't, uh, I mean, shuffle these two numbers when you take it out, but because when it comes to theta, when we take it as an inverse value, tan inverse, sine inverse or cos inverse value, we should use the, or we should follow the exact format, 8 divided by 6. And you can use, you can put the same thing in the scientific calculator, because there's a, on top of the tan button in the scientific calculator, there's a text with the tan minus 1 denotation, right? To access for that denotation, you should either press the depending on the color of that text, you can either press the shift button or the alpha button of your calculator and put the values, right? So now the angle they have given it as 53.13 degrees, right? Okay. So those are the three scenarios we have discussed so far. Right. Now we can move into the somewhat advanced trigonometric functions, right? Somewhat advanced trigonometric functions. In this case, we are going to learn about the cosine rule, okay? Cosine rule. This exact rule can be seen in the MCQ questions, right? Up to this point, we have discussed about the trigonometry and several ways of questions coming on and these three functions, right? Actually, these are very easy things. They are not directly asked in this type of questions. But however, we can expect this cosine rule to be there, and it is also very easy rule to follow. Okay. For before remembering the cosine rule, there's a specific format actually you have to remember. This is the format, okay? Whatever the triangle you have, let's say this is my triangle, okay? This is my triangle. Before applying the cosine rule, you should always denote the sides and the angles according to the specific way, okay? Now you can see here, angles can be given by capital A, right? This is capital A angle. This is capital B angle and capital C angle. And opposite to the angle, then I can denote the length of the opposite of the angle as simple A. So opposite to the capital B angle is the simple B length. Opposite to the capital C angle is the simple C. So this is the denotation. I think it is not very hard to remember, right? You can just denote it like it, right? Then you can have three different formulas. It is also very easy to remember. Now, in the left side triangle, you can see this is the angle capital A. In front of that, you have the simple A. Now, as I said earlier, to use the trigonometry, you should at least have, at least you have two sides has to be known, or one side and one angle to be known, or two angles to be known. Let's say you have given with the three data here. Three data is more than enough, okay? More than enough. And actually we are using this cosine rule when we cannot if the triangle is not a if it is not, if the triangle is not satisfying with the Pythagoras theorem, which means that the triangle is not a right angle, then you have to use the cosine rule. Okay, 90 degree angle එකක් නැත්නම් අපි cosine rule එක තමයි පාවිච්චි කරන්න ඕනේ. මොකද Pythagoras theorem එක applicable නැති හින්දා. Cosine rule එකේදී you only need to have two lengths, right? Two lengths and one angle. Two lengths and one angle. Two angles. Let's say I will denote it like this. Okay, sorry, this should be, it should be one angle and two known sides, right? If you know the two sides and one angle, obviously not a Pythagoras theorem, not a right angle triangle, right? If you satisfy these three conditions, you can use the cosine rule. Now let's see how to determine how this equation has been formulated. Okay, what is the part we are going to find here? What is the part we need to find here? We need to find what is this simple A length. Okay, what is the simple A length? BC දීලා තියෙනවා, simple BC angle එකක් දන්නවා. කියන්නේ if we already know the angle adjacent to the two sides, if we know the adjacent two sides and that angle, you can find out the opposite of that length, opposite side length. This is the equation. I hope you can clearly see the equation. Let me zoom it. Okay, so the equation goes like this. A square is equal to, this is the one we need to find out, b square plus c square minus 2 times bc multiplied by cos capital A. bc multiplied by cos capital A, right? So obviously there is actually a pattern in here. Okay, can you see? If you need to find out the A value, BC known values has to be first of all squared. Okay, squared, and they should be added with each other. Then there's a minus term with another multiplication. 2 times the known distances. 2 times BC multiplied by cos times the angle. Right. So let's go to the other equations as well. I think you can find out more interesting. Okay. So can you see the law of cosines, the three equations? We first of all discuss about the first equation here. A square is equal to b square plus c square minus 2bc cos A. And read down the other equations as well. I will again draw a simple triangle and the denotations. Here we have the capital A, here capital B, capital C. Or sometimes in several questions, sometimes the equation might be other way. Okay, this is going to be simple A, and otherwise the length is going to be sometimes capital A. It doesn't matter actually. So this is going to be simple A, simple B, and simple C. Look at the next one. If you need to find out the B length, what are the things you have to know? You should know the C value, A value, and the B angle, right? With that, you can find out the B value. B squared is equal to A square plus C square minus 2AC cos B. And the exact opposite, right? And the exact opposite is going to be Let's say you need to find out the c square, then you should know the a and the b, then the cos c angle, right? So obviously you can see there's a connection, small similarities between equations, right? And this is a practical example. Here we need to find out the length length of the AB. Okay, this length we need to find out. And if you can clearly see the diagram, okay, if you can see the diagram clearly, here you can see the B, C, and A triangle. And what are the things they have given in here? They have given the capital C angle 93 degrees and the adjacent two angles, right? Sorry, not the angles, the sides. So how do you denote this one first of all? So if this is the B, this is going to be the simple B. If this is A angle, this is going to be the simple A. And what is the equation we can use? C square, this is the simple C or the AB length, right? Or you can just write down AB squared or C squared is equal to A plus A square plus B square minus 2AB cos capital C. And you should always remember it. You should be very careful when you apply this one for equation, because uh, when you apply this or solve this one using a calculator, you should always put some brackets in here, right? Otherwise, the value is going to be wrong, right? 13 square plus 20 square, 2 multiplied by 13 multiplied by 20 multiplied by cos 93 angle. Now, AB length is how much then? AB length is how much then? Not 596. Okay, this is not final answer. You have to square it. So the answer is like 14. And let me ask you this question, where we can use the cosine rule now. First of all, that the obviously the triangle should not satisfy the Pythagoras theorem, or it should not be a right triangle triangle. Otherwise, we can use the Pythagoras theorem. And also, we should know the two sides and the adjacent angle in between the sides. And that is the only requirement. Okay. And next one is the sine rule. This is also another rule you can apply, right? It is somewhat easy to remember actually. Uh, as I recall the cosine rule denotation, it is the exact same for the sine rule as well. Okay. Can you see here? So this is the capital A angle. Opposite to that, we have the simple A length. Capital C, simple A length. Capital B angle, simple B length. Now this is the angle. Sorry, this is the sine rule. Sine A divided by sine angle divided by the length of the opposite side. Sine A divided by A is equal to sine B divided by B is equal to sine C divided by C. Remember, with the sine, you should always apply the angles, okay? Not the distances. අපි මෙතන හැම වෙලේම apply කරන්න ඕනේ angles. What is the importance of using the sine rule? You can say the same thing, right? Not a right angle triangle. And what are the requirements? What are the requirements? You don't need much, right? You can either use these two equations or these two equations, or otherwise you can compare it with this one to this one, because all of them are equal to the same thing. All of them are equal to each other, right? And another thing is that you can transport or the change the sides as well. It is okay to have c divided by sine c. However, it is equal to simple b divided by sine b. Okay, like that you can have the room for the opposite sides as well. Okay, let's do some questions from this one. Right. Now, in this case, you can see this is not a right angle triangle. Okay. Uh, right. However, you can see that two angles were given and one distance. And as I again recall that, as I again recall, if you have at least two angles, you can find out anything, right? However, it is only limited to the Pythagoras theorem satisfied triangles. But in this case, you have another data, the length, the simple b, you know, right? You have the simple b, it is equal to 15. The sine b is equal to 92 degrees, sine c is equal to 28. You can find out this length as well as this angle, because it is already mentioned in the equation, right? However, in this question, they are asking us to find out what is the AB distance, right? We need to find out distance from A to B, okay? Which means what? What is the term? What is the denotation? It should be C, right? Because here it is the capital C. In front of that, you have the simple c. And what is the equation I can use? And you can see, you can compare it with this one, right? Sine b is equal to simple b here. Then you can write down equation like this. No need to write down the whole thing again and again. You can just say sine b is equal to sine c, right? And the division, and you can write down simple b and simple c. However, you need to find out the simple c, you know. Then I will convert this one. I will take the c to one side, okay? If you take the c to one side, what happen? C to this side means sine c divided by sine capital B, sine capital B, B, uh, just B come to this side, multiplied by simple B, right? Okay. Right. Then you can follow up this one. This is the answer, right? Sine 92 divided by 15, sine 28 divided by AB, right? You can take out the AB. Okay. And find out the answer. AB is actually 7. Like that, you can find out the BC length as well, okay? Without issue, you can find out the BC length. Right.